Okay, let's take a look at another trig application. So the height of the swing is modeled by the function h of t is equal to 35 sine 8 pi t plus 74, where the highest and lowest points. Once again, you're finding your maximum and minimum points. You got to think about h of t as a sine k t minus h plus c. Your maximum point is your amplitude a plus your horizontal axis. Your minimum point is your horizontal axis minus your amplitude, right? And in this case, to find the highest point, we know that h of t here is equal to 35 sine 8 pi t plus 74, right? This 35 here would represent the amplitude, right? The 8 pi here represents the frequency, t represents the period, right? There is no phase shift, h is equal to 0. 74 represents the horizontal axis. Sorry, the 74 represents the horizontal axis, right? And if you want to find your maximum point, you basically do amplitude, or horizontal axis, 74, plus the amplitude, which is 35, which is 109. Okay, so 109, and we can look at height of a swing. Let's say it's 109 meters. The minimum point here is the horizontal axis 74 minus the amplitude 35, which is going to give you approximately 39 meters. Okay, so therefore the minimum height of this swing is 39 meters, and the maximum height is 109 meters. Okay, so that's the idea. Okay, let's determine the function of cosine that has an amplitude of 2 and a period of 2 pi and has a point at 0 and 1. Okay, so if we're looking at a function of cosine, and it's a periodic function, let's think about this in the form of f of x is equal to a cosine k x minus h plus c. And just to recap, we can understand that a here is your amplitude, right? K here is your frequency, x here is the period, right? It's also your variable. H here is your horizontal shift, and c here is your horizontal axis. Okay, so we're just looking at this in terms of behavior. So we know that the amplitude is 2, so f of x here is equal to 2 cosine. The period is 2 pi, right? So k times x should equal 2 pi. If the period is 2 pi, k times 2 pi is equal to 2 pi. Therefore, k should be equal to 1. Okay, so k is 1, so you don't have to write it. It doesn't say anything about the horizontal shift, so I'm just going to let h equal 0. So let's just do cosine x. Actually, you know what? We do need to figure out the horizontal shift because of the fact that they did give us a point. So we'll do x minus h plus c, right? And it doesn't tell us anything about the horizontal axis, right? So it doesn't tell us anything about the horizontal axis. What we could do here is we could just let c equal 0. Okay, so f of x is equal to 2 cosine x minus h. Okay, we know that the point f of 0 is equal to 1, so if I plug this in, f of 0 is equal to 2 cosine 0 minus h is equal to 1. If you want to solve for h, right, what you could do here is you can just divide this by 2 and this by 2. So cosine negative h is equal to 1/2, which is basically 0.5, right? And if you want to solve for h, I'm just going to get rid of the cosine. And the way I'm going to do this, I'm just going to do the cosine inverse. I'm going to do the same thing out here. Cosine inverse and cosine cancel out. Negative h is equal to the cosine inverse of 1/2. One of the possible solutions is 60, right, degrees, or you can write this as pi over 3 radians. Okay, I prefer radians, right, because we're looking at everything in radians. So h is equal to negative pi over 3. So if h is equal to negative pi over 3, then f of x should be equal to 2 cosine, because h is negative pi over 3, you'll have x minus negative pi over 3, which is 2 cosine x plus pi over 3. Okay, so this is your function. The height of a chair on a Ferris wheel is described by the function h of t is equal to 15 cosine pi over 3 t minus 4 plus 18, where h is in meters. What are the possible heights you can be if you're riding the Ferris wheel? So when they're asking us what the possible heights are, we're basically looking at the range of the function, right? So we know that our periodic function, the height of the Ferris wheel, is in the form of h of t is equal to a cosine k t minus h plus 18. A here is the amplitude, k here is the frequency, h is the horizontal shift, and 18 here, this value here is the horizontal axis. We know that the range of a periodic function is between the minimum value and the maximum value. So what we need to do here is figure out what that range is, right? Because the range is the range of the height values that can possibly exist. The minimum value here is your horizontal axis, c, right? Oh shoot, I should have wrote c instead of 18 here. Sorry about that, right? The minimum value here is c minus the amplitude. The maximum value is the horizontal axis plus the amplitude. In our format, h of t is equal to 15 cosine pi over 3 t minus 4 plus 18. If I factor this guy out, 15 cosine pi over 3 factor t minus, what you want to do is you want to find a value that multiplies by pi over 3 to get you 4. So easy way to do that, I'm going to do 4 divided by pi over 3. So it's 4 times 3 over pi, which is 12 over pi. So minus 12 over pi plus 18, right? And we can notice here that our amplitude is 15. Maybe let's just use a different color for this. Our amplitude here is 15. Our horizontal axis here is 18, right? And we can actually find our minimum and maximum by using the amplitude and horizontal axis. So the horizontal axis is 18 minus the amplitude 15, which is 3. So the minimum value or the minimum height is 3 meters, right? Because height is in meters. And the maximum height is 18 plus the amplitude, which is 15, which is going to give us 33. Okay, so this is basically our maximum height. So the range of possible values of height are between 3 meters and 33 meters. Okay, so the possible heights will range from 3 to 33 meters. All right, let's take a look at another trigonometric application. The temperature of a swimming pool is cyclic and modeled by a trigonometric function. If its its temperature is 82 degrees Fahrenheit, and its lowest temperature is 76 degrees Fahrenheit, and it takes 12 hours for the temperature to change between its extremes, what equation models the temperature of the pool as a function of time in hours? Okay, so we know that this temperature is cyclic, right? The temperature is dependent on time and it's cyclic. So if it's cyclic, we can use a periodic function, also known as a sinusoidal function, to represent its temperature as a function of time. Maximum temperature is 82 degrees Fahrenheit. The minimum temperature is 76 degrees Fahrenheit. And to go from the maximum to the minimum, it takes approximately 12 hours. To go from one extrema to the other extrema, this is 1/2 of a period. So a full period here is 24 hours. Right? If half a period is 12 hours, then 24 hours is one period. Okay? So what equation models the temperature of the pool as a function of time in hours? So what I'm going to do here is I'm going to create a function. So I'm going to let f of t, actually, you know what? T of t represent the temperature of the pool in degrees Fahrenheit after t hours. Okay. And in this case, they're modeling it using a cosine function. Now, it doesn't tell us where it starts, right? If we start at the lowest point or the lowest temperature, then we're going to be using negative cosine. If we start at the highest temperature, we're going to be using positive cosine. Now, there isn't any negative cosine here, so I'm going to use the positive cosine functions. So let's say that at time 0, we're at maximum temperature, right? So at time 0, we're at 82 degrees Fahrenheit, so we're starting at the maximum. Because we're starting at the maximum, we know that the positive cosine function starts at the maximum, then goes to the horizontal axis, right? So because we're using the positive cosine function, we need to start at the maximum. And this would allow us to have a phase shift or a horizontal shift of 0. Now, in this case, we want to express the function's template as a cosine k t minus h plus c, right? And I want to find some of these players, basically, right? So we know that phase shift here is 0, right? So we don't have to worry about that, right? I need to solve for my a value, my k value, and my c value. Now t here is the period, right? This is the amplitude. K is the frequency. You might see different variables. These are just the variables I commonly use. And then this C here is the horizontal axis. Okay, so let's start with the amplitude. First, the amplitude here is maximum point minus the minimum point divided by 2. So the maximum here is 82. The minimum here is 76. You're going to divide this by 2, which is 6 over 2, which is 3. Right? Then we're going to look at the horizontal axis, which is the maximum point plus the minimum point divided by 2, which is 82 plus 76 divided by 2, which is 158 over 2. If I divide this, that's going to give me 79. Okay, so the 79 is the horizontal axis. We need to also find the frequency. Well, we know that the frequency here, we know that the period is 24 hours. So k times t should give us 2 pi. So k times 24 is equal to 2 pi. K is equal to 2 pi over 24, which you can reduce this as pi over 12. Okay, so k is equal to pi over 12, right? So the equation here, and I think, well, they don't reduce it, so we can write it as 2 pi over 24. It's the same thing. So from everything we've gathered so far, our equation, t of t is equal to a, which is 3, cosine k, which is pi over 12, t plus 79. So the closest function that it's going to resemble here is basically going to be part D. Okay? Oh, sorry about that, not part D, part C, because the amplitude here should be 3. But wait, part C doesn't actually have, no, it's not part C, because this is sine. It's not part D either, so it's part B. Sorry about that, guys. So the answer here should be part B, right? So answer here should be B, and this is our equation of our trig function. Okay, let's take a look at another trig application, sinusoidal functions. So if a bicycle wheel makes 5 rotations a second, so 5 revolutions per second, and has a diameter of 80 centimeters, so the diameter here is 80 centimeters, what cosine function describes the height of a point on the end of a wheel? So it kind of helps to draw this out. This is our wheel. Okay, and then we can imagine that the diameter of that wheel from the center is 80 centimeters, right? If you're looking at the height of a point on the end of the wheel, we need to start from one point. So let's say that we're looking at starting here. Okay, at time 0, we start at the very bottom of the wheel, right? And if you're looking at a cosine function to model this, because we're starting at the minimum point at time 0, a minimum point, you're going to have to use y is equal to negative cosine x to model this. And the reason I'm using negative cosine x is because negative cosine x at 0 will start at the minimum point. It'll start at -1. This is pi over 2, right? And then it'll go to the horizontal axis. And then at pi, it'll go to its maximum point 1. Okay, so that's why I'm using the negative cosine function to model this. right? So we can understand that the function, I'll let h of t represent the height of a point from the bottom of the wheel at bottom of the wheel after, let's do t seconds in centimeters. Okay, so we'll look at height in centimeters after t seconds from a point on the bottom of the wheel. Now we also know that the maximum height here, so the minimum height here should be 0 meters, but the maximum height here should be 0 centimeters. We're working with centimeters, and the maximum height here should be 80 centimeters. Okay, the equation that we are trying to model here, I'm going to show you that template in different color. H of t here is equal to negative a cosine k t minus h plus c, right? And the amplitude here, a, can be written as maximum minus the minimum point divided by 2, which is basically 80, minus 0 divided by 2, which is 40. And the horizontal axis, c, is maximum plus minimum divided by 2, which is 80, plus 0 divided by 2, which is 40. Right? So the amplitude and horizontal axis are both 40. Right? Now we also need to solve for, so we need to solve for a, we need to solve for k. Now the horizontal shift should be 0 if you model it using the appropriate function. So because this function does start at the bottom, at the lowest point, just like it's modeled negative cosine function, the phase shift actually would be 0, and you can actually prove this by testing a point. So h is going to be 0, so we don't need to solve for that. We just need to solve for c, k, and a. Okay, now we solve for a and we solve for c, so let's solve for k now. K is the frequency, k times the period, so kt is equal to 2 pi radians, right? K is the number of revolutions that occur in a 2 pi degree stretch, which is a revolution, which is basically 1 revolution. We're told that the speed of the wheel is 5 revolutions a second, right? So if we have 5 revolutions a second, we know that 5 revolutions are basically 2 pi radians per revolution. So in this case, we can get, that's 10 pi radians. So 5 revolution is 10 pi radians, right? So we have 10 pi radians in a second. Well, we want to figure out how long does it take for 1 revolution, right, which is 2 pi radians. So I'm just going to divide by 5. So 2 pi radians is basically found in 0.2 seconds. Okay, so the time here is 0.2 seconds, and the k value here, so the period is 0.2 seconds, the time it takes for 1 revolution. K here is 2 pi divided by 0.2, which is basically 10 pi. Okay, so it's basically 10 pi, right? So it's literally the same thing as me figuring out the angle equivalent of the revolutions, right? So I just wanted to kind of show you that both ways, right? So we have 10 pi. So now that we have the k value, we have the c value, we have the a value, collectively our cosine function, h of t, is equal to a, which is 40, negative 40 cosine, k in this case is 10 pi, t, h is 0, plus 40. Okay, so this is basically our value. Okay, so this is the function that will describe the height of the point at the end of the wheel. Okay, let's take a look at another trig application of trig functions, periodic functions. A pinwheel's axle stands 17 centimeters above ground. The edge of the pinwheel is at its lowest point pi seconds after it starts spinning and is 11 centimeters from the ground what function best describes the height of the edge of the pinwheel? Okay, so think about the pinwheel like this. Okay, and we know that at pi seconds, we're 11 centimeters from the ground, and that's going to be the lowest point, right? So let's say we know that the pinwheel itself, the axle, is 17 centimeters off the ground. So all of this, let's say this is the ground here. This distance here from this axle is 17 centimeters. Okay, and the lowest point here occurs at 11 centimeters. Okay, and this occurs pi seconds. So I'm going to say all the points that we're going to be representing are t and h of t. All right, and h of t, let h of t represent the height of the edge of the pinwheel after t seconds from the ground in centimeters. Okay, so it's basically the height, let h of t represent the height of the edge of the pinwheel after t seconds from the ground in centimeters, right? And then this is basically what we're trying to figure out. We can understand that the pinwheel's axle should act as the radius, right? So this point here should be 6 centimeters. As a result, because it is a radius from the center, then this also should be 6 centimeters. So the maximum height here should essentially be 23 centimeters from the ground. Okay, so this should be 23 centimeters from the ground. What function best describes the height of the edge of the pinwheel? Okay, so if we're looking at a function from the edge of the pinwheel, let's say that we are using a positive cosine function. Well, if you're using a positive cosine function, right, h of t is equal to a cosine kt minus h plus c. Now, as long as if we're using a positive cosine function will start at 0 at its maximum point. Okay, so it's going to start at 1, then it's going to end up at the horizontal axis at pi over 2, and so forth, right? And at pi, it's going to reach its negative. It's going to reach its lowest point. So because it starts at a maximum, as long as we stick to that notion, then the horizontal shift is going to be 0. Okay, so if we start at the maximum point at time is equal to 0, then the horizontal shift would be 0. So what we can do here is we need to figure out our amplitude, our frequency, right, our period, our horizontal axis, and we can also test to show that this should be equal to 0, right, our horizontal shift. Okay, so let's start by finding our amplitude. Now, just from this diagram, we can understand that our maximum point here is 23. Our minimum point here is 11. We know that the amplitude is maximum minus minimum divided by 2, which is basically 23 minus 11 divided by 2, which is 12 divided by 2, which is 6. Okay, so the amplitude is 6, and this is basically consistent with the radius of the pinwheel, right? If you want to figure out the horizontal axis, it's the midpoint of the maximum minimum point divided by 2, which is 23 plus 11 divided by 2, which is basically 34 divided by 2, which is 17. Okay, so the horizontal axis here, the horizontal axis here is 17. Okay, and this is consistent with our midpoint or our axle, right? A distance of our axle from the ground, right? So c is equal to 17, and in that sense, if I plug this into my equation, a here should be equal to 6 cosine k here we haven't found yet. If we want to find k is our frequency. K times the period t is equal to 2 pi radians. We're given that the edge of the pinwheel is at its lowest point after pi seconds, right? So what that tells us is that if we started at time is equal to 0 and we ended up when we started at as maximum point, we ended up as minimum point in pi seconds, and that represents a half a period, right? So from the maximum to the minimum, it took us pi seconds, and this is 1/2 a period. So if 1/2 a period is equal to pi seconds, then a full period here should be 2 pi seconds, right? So using that notion, then k here, k times 2 pi is equal to 2 pi, so therefore k is equal to 1. So k is basically going to be equal to 1. So I don't have to look at my value of k, and because this mirrors my function that I started at my maximum point, there is no horizontal shift. So h will also be equal to 0. So if you model it properly with the right template, then you don't have to worry about the horizontal shift, right? So now we have 6 cosine t plus, and then the horizontal shift here, the horizontal axis was 17. So the function here, h of t, is equal to 6 cosine t plus 17. So your answer is going to be A. Use the sine function to describe the height of the tides of the ocean if high tide raises the water level to 4 meters at noon and low tide drops it from 1 meter at 4 p.m. And let t equal 0 be 12 noon, right? So 12 p.m. noon is the initial starting point. Okay, and we know that at low tide, the lowest height of the tide here is going to be 1 meter. So this is the minimum, right? High tide is going to be 4 meters, which is the maximum, right? And we know that at noon we start at high tide, right? So at noon, basically time is equal to 0, we start at high tide. Okay, so technically you would use a cosine function, a positive cosine function, to model this, but here they're asking us to use a sine function, right? So it doesn't really matter because both functions will mean the same thing, except we might have a horizontal shift as a result. So I'm going to let h of t represent the height of the ocean in meters, t hours after noon. Okay, so we're going to look at it as t hours after noon. If t is equal to 0, we're at noon, right? So that's the 12 p.m. mark. So I'm going to model this as a sinusoidal function. H of t is equal to a sine k t minus h plus c, right? And in this case, a is the amplitude, k is the frequency. So amplitude, k is the frequency. Right, this t here represents the period. This h here is the horizontal shift. And the c here is the vertical shift. Right? Well, in this case, we want to look at this as the horizontal axis, right? Because we were just looking at behavior. Okay, so we know that the maximum point here is 4 meters. We know that the minimum point here is 1 meter, right? And we know that the amplitude can be discovered by maximum minus minimum divided by 2, right? So the amplitude here is 4 minus 1 over 2, and that's going to be 3 over 2. So the amplitude is 1.5. The horizontal axis, C, is the maximum plus minimum. It's the midpoint between the maximum and minimum points over 2, which is basically 4 plus 1 over 2, which is 5 over 2, which is 2.5. Okay, so this is your horizontal axis, this is your amplitude. You can discover both of those by using the maximum and minimum points. We're also given the piece of information that high tide starts at noon and low tide occurs at 4 p.m., right? So from high tide to low tide, from maximum to minimum, it's a span of 4 hours. Okay. This represents, so when you go from your maximum to your minimum point, that represents 1/2 a period. 1/2 a period, 1/2 t in this case, is equal to 4 hours. So a full period here should be 8 hours. If you multiply this by 2 and this by 2. Okay, so a full period is 8 hours. Once we have your period, the frequency, we know that k times t should be equal to 2 pi radians. Okay, so k is your frequency. It's the number of cycles that occur in one revolution, or a 2 pi stretch. K here is equal to 2 pi over t. K here is equal to 2 pi over 8. K is equal to pi over 4 if you simplify it. Okay, so k, the frequency is pi over 4, right? And in that sense, you basically have your amplitude, your horizontal axis, your k value. Now all you got to do is solve for your h value. Now in order to solve for h value, this is what our function looks like so far. H of t here is equal to a, which is 1.5, sine k, which is pi over 4, t minus h, plus c, which is 2.5. I need to plug in a point to solve for h. In order to plug in a point to solve for h, I know that at 0, right, we start at high tide, which is basically 4 meters. Okay, so h of 0 should be equal to 4. Okay, so I'm going to plug that in into my function. So h of 0 here is equal to 1.5 sine pi over 4, 0 minus h, plus 2.5 is equal to 4. Then move the 2.5 to this side, you get 1.5 sine pi over 4 negative h, right? Negative pi over 4 times h was equal to 4 minus 2.5, which is 1.5. Then what I'm going to do is I'm going to divide by 1.5 to both sides. If I divide by 1.5 to both sides, we get sine negative pi over 4 times h is equal to 1. And then what you want to do to get rid of the sine, I'm going to do the sine inverse. So I'm going to do the sine inverse here. And whatever I do to that side, I have to repeat to the other side. So sine and the sine inverse cancel out. And you're left with negative pi over 4h is equal to sine inverse of 1. If you plug in your calculator, you should get pi over 2. That's 90 degrees, right? And h here is basically pi over 2 divided by negative pi over 4, which in this case is basically going to be pi over 2 times negative 4 over pi. Cancels out, h is equal to negative 2. Okay, so therefore your function, your phase shift is negative 2, so your function, your sine function, h of t is equal to 1.5 sine pi over 4 t, because it's t minus h and h is negative 2, t plus 2 plus 2.5. Okay, so that is your sine function. Okay, so this, using the sine function, you can determine what the height of the ocean is, the wave is after a certain amount of time, t, in hours after noon.